In this presentation I'm going to show you how to manipulate signals. I'm going to use audio signals because you'll be able to hear the effect of the manipulation. So I've uploaded some audio files up onto this website. So there are three WAV files: bass, drums and guitar, which I'll use in this presentation. So the first thing you should do is download those files. I have already downloaded them and they're in this directory up here. So first thing I'm going to do is read in those WAV files. So I'm going to use a function called wavread to do that. So first one is bass.wav, and I can read it in using my function. I have to specify the path on the file, and I need to do that with all three signals. So I'm going to use the up arrow key to go through the history of commands, save myself some time. Call this one git, GUIT, and the last one drums. Now, each of those signals is quite long. They are all just sequence of numbers, and I'll just show you the sequence of numbers by typing the name of the variable at the command line and hitting return. You can see it's just this long sequence of numbers. Now I can stop those sequence of numbers being displayed by hitting Control C. But all those numbers are numerical values that represent the audio signal. Now they're quite long. If I looked at the length of the drums, I see that it's 4,725,975 samples, which is quite long. In terms of seconds, we can divide by the sampling rate. Now each of those files are recorded at CD quality, and CD quality is 44,100 samples. So in this case the drums signals is 107 seconds long. That's quite long, so I'm going to create a variable which is a segment of that, and I might grab let's see, from the 10th second, which would be 10th second would be 44,100 multiplied by 10, up to, and this is where the colon operator, it's a very useful operator in Matlab. It specifies a range. So from 44,100 multiplied by 10, which is 441,000 samples, up to 44,100 by 20. Okay, so what I've done here is I've said take from my original drums signal, I want to extract out a range of samples, and this really says from 10 seconds up to 20 seconds. So it's a very easy thing to do. Now I can plot that drum segment, plot drum seg, so we can visualize it. There's my drum segment there, and you can see there are a number of drum beats. There's about 12 or so there, and now we can use another built-in function in Matlab called sound to play that back. Sound drum seg 44,100. That's the sampling rate at which it plays back. Okay. Now we could change the sampling rate at which that was played back, and it would sound quite different. So we play it back at a higher sampling rate, and it should play back at a quicker rate. So the sound card on my laptop is interpreting the signal to be different than before. It's interpreting that the signal was 88,000 samples per second rather than 44,000. That's why it was played at a quicker rate. The next useful thing that it would be useful to show you, I'll actually make a new variable called D. I will just take 1 second of drums. So let's take from the 12th second up to the 13th second. I made a mistake, that shouldn't be called, that should be a multiply. Okay, so that's 1 second. Now it's nice sometimes to repeat segments, so we'll just listen to the D signal first of all. play it back at 44,100. So that's 1 second of the drum signal. And what I'll do now is I'll repeat that segment. So we'll call it drum repeat for want of a better name. And we can do that very easily in Matlab just by putting, let's see, D, where's D, colon D, colon D. And that repeats that sequence 3 times. I don't need that colon there. And let's just see the size of D repeat versus the size of D. So D repeat is 3 times the length of D. And if we listen to that, you'll hear what I mean. Specify the sampling rate. So it repeated the D variable 3 times just by basically I've concatenated those 3 together. It's important that you know that the colon is used to concatenate signals that are column vectors. And let's see why I'm saying D is a column vector. Anytime you get the size of a variable, that'll tell you the number of rows by the number of columns. This is 1 column of data, D is, okay? But it's 44,101 rows of data, okay? So if you can visualize it as an array. Now, when I use the colon operator on D, I increased the length of the column by a factor of 3. Let's just show you what would happen if I didn't use the column vector or the semicolon. I'll use a comma instead. And we look at the size of D now. You'll see that it's the same number of rows. D repeat will be the same number of rows. Oh, that should be D repeat. Mistake. Okay, so we have the same number of rows as D, but now it's 3 columns of data. And I can show you that now. You can see the 3 rows, or sorry, the 3 columns of data there. 1, 2, 3. Okay. There are the 3 columns. Okay, so that's just something to be aware of whenever you're concatenating, that you need to know whether you're concatenating row data or column data, because you need to use the comma or the semicolon depending on the data you're dealing with. Okay, now where was I? I have the drum segment read in. Okay, so we've got 10 seconds of the drum segment. Let's maybe take in 10 seconds of the guitar as well. We'll take the same 10 seconds so that it sounds nicely when I'm going to play them together soon. And then with the bass. Now each of these variables, drum seg, guitar seg and bass seg, are all the same length. I might actually make them a slightly different length just to show you what happens when you try to add signals that are of a different length. But what I'd like to do is make a composite signal, which is a combination of all 3. So I'll just add the drum seg with the guitar seg first of all. And all I've done is added 2 sequences of numbers. Drum seg is 1 sequence of numbers, guitar seg is another, and the comp is going to be the combination of both. And I can listen to that. And you can hear the guitar there and the drums together. I'm also going to now, I'm going to try to add the bass in. And I'm going to show you a very common error that occurs. Oh, not bass comp, bass seg. this error here, matrix dimensions must agree. You get this error whenever segments or signals that you're adding together or manipulating aren't of the same length. So base seg is 20 seconds long, whereas the other two are 10 seconds long. So to correct that, I need to make sure that they're all of the same duration. There's my composite. Now let's listen to that composite again. Now the bass is very low compared to the other two. So what I'm going to do is increase the amplitude of the bass. And that can be achieved very easily by just multiplying all the numerical values associated with the bass signal by 3. Okay? And I'll reduce the amplitude of the guitar segment. Say 0.15. Okay, so now I've changed the relative amplitudes of both of those signals, and when I add them together again, and I'm going to play that back, you should hear the bass being much more prominent than the guitar this time around. Okay. So that's some basic manipulation like that, and if I wanted to repeat that, we've already seen how to repeat that sequence. That's not a problem. The next thing that might be useful to know is how to gradually change the amplitude of one of those components. So let's say the drum segment. Imagine that I wanted to gradually increase the amplitude of the drums, so they weren't so prominent at the start but became more prominent as you went along. To do that, I could make use of a ramp signal. So a ramp signal would look amplitude versus time. A ramp would start off at 0 and gradually increase. And if I multiplied this ramp signal by, say, the drum segment, then I could gradually increase the amplitude of the drum. So let's just see how to do that now. So I'm going to plot the drum segment first of all. So there's my drum segment, and really what I want to do is for the early drum beats to be of low amplitude and to gradually increase as I go along. So I'm going to create a ramp function first of all. I'll call it ramp, and I want it to start off at 0, and again my colon operator comes into play. I want to go from 0 up to 1, and I need to do it in steps of, well, let's say I gradually increase it over 8 seconds. Then I would need to go from 0 up to 1 in small increments, and the small increments will be 1 divided by 44,000 by 7. And I'll just create a new figure, and I'll show you that ramp. So there's my ramp signal. You can see that it gradually increases. Okay. Now let's see the size of my ramp, and you can see that it's not a column vector, it's a row vector, whereas my drum segment is a column vector. So I can tell you that I'm going to have difficulty multiplying these, and I'll just show you the error again that you will get. There's two problems. First of all, the drum segment needs to be of the same length. So if I say drum seg equals drum seg dot multiplied by ramp, I'm going to get an error. I get this problem that the dimensions don't agree. First thing I might try to do is make the drum segment be the same length as the ramp. I think the easiest way to do that would be create a new variable called n, which is equal to the length of the ramp. Now if I say drum seg 1 to n, which is the first 308,701 samples, if I say that's equal to drum seg dot multiplied by ramp, I will still get an error. because again the dimensions don't agree. And this time it's just that this variable is a column vector, whereas the ramp is a row vector. Okay, so what I'm going to do is transpose the ramp. Well, let's check the size of the ramp now. So it's converted into a column vector, and this is just something you need to get used to with Matlab when you're dealing with rows and vectors. So now let's redo the command up above. We should have no problem. Okay, so that made the first 308,701 samples of this drum seg. It changed it, and we can see how it changed it by, well, there's the original drum segment. Now let's hold on and plot drum segment in red. There we go, and you can see that the red signal is the new drum segment and the amplitude is gradually increasing. So now let's create our composite again. My drum segment is new. This would be actually an important note as well, that the comp variable won't be updated with my new drum segment until I run this command again. So I need to run that again. And now let's listen to the composite. Now you can hear the drum gradually getting louder there. The last thing that might be useful in terms of audio manipulation only is to create stereo signals rather than mono signals. A stereo signal, the two channels can be of different amplitude. So I'm going to make each one of these a stereo signal, and it's very easy to do. You'll see that the size of the guitar is just a one column vector. We'll just recreate it. Well, that should have been size guitar seg. Okay, very similar, only a different length. But let's make guitar seg a stereo signal by making two channels. That's easy to do. We just need to concatenate the two using the comma rather than the colon. If the colon, if I use the word concatenate, that's not correct. But if I use the colon, they would be concatenated, which means that one will be added to the end of the other. Maybe it's best just to show you what happens. They should be git seg. So let's check out the size of git seg now. So you'll see now it's got two channels as opposed to one. Now with the stereo signal, you can make a sound appear to be further from the left hand side than the right hand side. So you can create what's called a stereo field. So instead of I made a mistake there. Let's see if I can go back. I'm going to create the mono signal again. There. And I don't want to overwrite git seg. I will just call it git. I'll call it git stereo. But I'm going to make the left hand side stronger than the right hand side. So I'll multiply the left hand side by 0.8 and multiply the right hand side by 0.2. Okay. And I'll create a bass as well, bass stereo, which again I need to be two channels. We'll call it bass seg. This time we'll do the opposite. We'll make it sound like it's coming stronger from the right hand side than the left. Now, and let's create a drum stereo. Just notice a spelling mistake up there, it's no harm. Drum seg, and we'll make this one the same. It's equal strength in both left and right channels. Okay. Now let's create a new composite, adding them all together, and we'll listen to that. Okay, there you go. That's a demonstration of how to manipulate signals. We used audio as an example, but the same approach can be used for any signal if you want to break it up into segments and manipulate it or repeat signals. The most common, most important operator to get used to is this colon operator. It's probably one of the more unusual operators that doesn't appear in other languages, but it's very common in Matlab. Okay, thanks for your attention.